Hello, my name is Michael Krauss, and today we're going to talk about Podman. Podman is a container runtime environment like Docker that can run cross-platform, and it can be used as a container runtime for all your Kubernetes environments, whether it be a Raspberry Pi like this one, like those back there, or on your Windows, Mac devices, and of course, any Linux platform. And what we're going to do today is we're going to first review a little bit on, just do some review background on what containers are. And then we're going to dive into why you might want to choose Podman for your container runtime of choice. So here we show, on the left, we show three different very popular container platforms. Docker, I'm sure you all have heard of. Containerd, if you run lightweight Kubernetes, such as Micro K8s that I'm running on my Raspberry Pis back here. That's going to be the default install. And Podman, which is a Docker compatible container runtime. And that's going to be the default if you install Red Hat Enterprise Linux. You can run Docker on RHEL too, but Podman would be the default that would be installed. If you are running Red Hat's enterprise ready Kubernetes environment called OpenShift, Podman is the container runtime there as well. So let's take a look at why you'd want to even choose to use Kubernetes in the first place. Well, developers needed a way to be able to package their app and all its dependencies in one spot and be able to run those portably on every operating system. Now, as you know, you can get VM Workstation, Parallels if you're on Mac. You can have a hypervisor, ESX server, Hyper-V, but those run virtual machines that are huge. They comprise the entire operating system, so they're not really good for developers to package apps and give a virtual machine for every single app. Containers, on the other hand, they all share the same kernel and the same OS underneath. They're faster, they're much easier for developers to use to package all the dependencies and everything in one spot and be able to run them on any operating system in any cloud anywhere. Now think of containers like a container ship out on the ocean. That container ship has thousands of containers. Each one of those containers are isolated from each other with their own products, but they all share the same ship, same captain, same crew. Now, liken that to if you liken container ships to Hyper-V or VMware, you would need a totally separate ship for every container, which does not scale very well. Even if you obviously be able to run smaller ships, but it would get out of hand in a hurry. So that's why containers make up the backbone of modern day DevOps, as well as cloud native applications. So now why would you choose Podman versus Docker? Docker is very good. Container runtime, it's been around forever. Docker repositories all over the place. And of course, as I did mention, you can use those Docker repositories with Podman. But one of the main points here is we're going to go through is to be able to run daemonless and rootless. And this poses some security advantages. Daemonless, let's start with that. Docker runs a central daemon and kicks off all the different containers and processes underneath that. If that Docker daemon crashes, you lose all your containers underneath. If you're running Podman, there is no dependency on a central daemon. It's daemonless, so all those containers run separately. There's a helper app that spawns with each container, and that's how it works. So it's much more isolated, much more crash proof, if you want to say it. Plus, the daemon by default, if you do a default install of Docker and you don't change anything, it's going to run all your containers as well as the daemon as the root user, which poses some security issues. And as we can see here in the next slide, there is a Docker rootless mode. Now, you can do that. It's not set up that way by default. There are some disadvantages running Docker rootless versus Podman. I'll go on that on the next section. However, the main point here I want to point out is it still runs that centralized daemon, whereas Podman launches what are called helper apps. Each process is called conman. And you can kind of see here that if you compare resources, memory usage, it's going to be a wash by the time you launch a bunch of containers. So if you're worried about, well, if it's launching a separate process for each container, is that going to eat up system resources? That's nothing to worry about. But now let's take a look at if you do decide to run the shell script to convert and reconfigure your Docker to Docker rootless. It's still going to run that daemon. Podman still has no daemon. There's going to be some network and shared user space or per container. There's some issues there. But the big thing I want to point out is, especially if you're running like on Red Hat Linux, SE Linux support, very limited. And with Podman, you get the full use of that. And if you don't know what SE Linux is, just think of it as a traffic cop. If somebody did hijack a process running as root user, SE Linux would police that and say, well, geez, HTTP Apache's running as root, and now I want to go look at some user files on the system because root has access. You're not going to be able to do that. SE Linux prevents that. I got another video explaining SE Linux if you want to check that out. But that's one of the advantages of Podman. Also, again, that isolation model, being able to isolate the apps so that it's not dependent on that central daemon, is very important. I'm going to demo that here right now. So here I have a Python app that is running on both Docker and on Podman. And if I go to my process tree and I filter on my app, you can kind of see that. I mean, take a guess. Which one of these processes is running Docker and which one is running under Podman? If you guess the mcropsy, my user ID is Podman, you guessed correct. Root is Docker. That's the default install. I just did a sudo apt get install of Docker. Same thing with Podman on one of the Raspberry Pis back here, and that's how it runs by default. Now let's take a look at, well, right here. If I do, first let's do a Podman process. You can see just like Docker PS, it does show my Python app running. I just want to kind of demonstrate that. Same commands. If you know Docker commands, you're going to know Podman commands. So let's do a PS tree and grep on, that's not going to work. Let's grep on Docker. Notice the dependencies on the daemon. The daemon runs, spawns the processes. But now let's take a look at, if I do the same thing looking for Podman. You see there's nothing. I have a Podman app, but it's not dependent on the Podman. There is no Podman daemon to be dependent on. So let's see what happens when I kill these processes. Okay, the Podman process has been stopped, but my web app, my Python app, is still running. Let's do the same thing for Docker. Docker is bigger. It's also, all the apps are dependent on Docker, so there's more to do when I say stop. So just give it a second here. It should stop right about there. Now, if I refresh the Docker app, notice it is no longer running. Podman, you need Podman running to be able to launch applications. Obviously, if it crashed or something, you'd want to get it restarted, but at least the apps that are running are going to stay running. If you're running in a Kubernetes environment that you're dynamically launching and relaunching apps, obviously that's Podman still has to run, but it is not, the apps are not dependent. So something, a hiccup or a restart, it's not going to affect the applications running. So I'm going to just go ahead here and restart that. And now you'll see my application comes back. So that is my brief introduction of Podman. Just barely what's under the hood. There's a lot more there, but feel free to ask any questions, or if you want to see more in-depth explanations, I'd be glad to do a more in-depth video. Thank you.